Thanks a lot for the introduction and thanks a lot for the invitation to speak today. As Gerd said already, the topic is cybersecurity as a central challenge for NextMobility. And to start with the talk, I have some small animation for NextMobility. So we have a not so NextMobility car, but before I dive deeper into the topic, let me briefly present to you what we do at the chair and what is the chair that I'm adding, because it gives a little bit of context of the domain and the tools and people I'm working with on a daily basis. So these are some of the members of our chair. I'm adding an industrial chair, which means that I have 6 industrial partners and several regional and institutional partners that I have continuous exchange with. And as a researcher, this is a perfect situation because it really enables you to continuously exchange and validate your research together with partners from industry and also from academia. It's a chair at IMT, and it's located at IMT at Montic in Rennes, where I'm also, and I have also at the chair PhD students that are at Telecom Paris and Telecom Sud Paris, which is great because cybersecurity is nothing local or limited to a certain domain, but it's something where people have to work together, and that really is a holistic process that involves a lot of different steps, and some of them we'll get to know today. From the industry side, I have the partners Airbus, Amosys, BNP Paribas, EDF, Nokia Bell Labs, and SNCF. For the smart mobility, especially SNCF is interesting because it's the train operator, and with the holistic ecosystem from stations over backend up to the trains themselves and many more aspects. But all the other partners are also very interesting in this domain. Plus, as regional partners, we also have the region, so this is interesting towards smart cities, for instance, and we have a cybersecurity excellence cluster, which is called Pôle d'Excellence Cyber, which is also very interesting because in there's the whole cybersecurity ecosystem in Brittany, but also in France, and these are great opportunities to do things together. At the chair, we have at the moment 8 plus 5 PhDs, we have 3 plus 1 postdocs, and some more stuff. But it's just interesting to see a little bit what are we doing, which workforce we have, so that we can really tackle lots of problems in that direction. And you're cordially invited to contact me, contact us, if you're interested in doing research together, coming over for doing some experimentation, and so on. So now let's dive a little bit deeper into the topic. So the chair is called Cybersecurity for Critical Network Infrastructures, and it's interesting to see what are these network infrastructures, and here we see already some examples from healthcare, water supply, energy, communication, computation, also cloud, data centers and so on, production, transportation, so this is especially interesting for us today, defense, also banking, research and education, agriculture, and many more aspects. And this is important to know because cybersecurity affects many areas of our everyday life and of everybody's everyday life. And this is the first key message to take home from today. The chair is organized in 4 axes that help to structure the cybersecurity space a bit. So the first one is security by design. So how can I secure systems the maximum possible? 100% is never possible because systems are dynamic. That means they interact with other systems, they interact with humans and so on. Therefore, this part is securing the most possible in advance. And the second is detection. So if we have the dynamic aspects of the system, how can we monitor them? How can we find out if something is not going into the desired direction? So these are the dynamic aspects. Then the third aspect here, mitigation. So if we found out that something is not going right, so we have anomalies, what can we do against it? Ideally automatically or autonomously, because then we're fast and also it's clear what's happening and we can take into account lots of data, but at the same time there are also ethical implications and so on if you do that. And the last one is this one here, bringing the human back in the loop, because on the one hand we want to have autonomous functionality, but on the other hand we also want to know what is happening, and in the end a human has to give the security goals, so what are the security goals of the system, and also take the final decisions, or at least be aware of what's happening there. Explainable AI is also an interesting topic in that direction. At the bottom you see some of the techniques that we're applying. So ethics are important whenever you do something autonomous. Then machine learning is an important tool for fuzzy processing of data, especially for the anomaly detection. Distributed ledgers are a good tool, helping to provide trust between non-trusting parties, and digital twins are also a key tool. And all these aspects I will cover a bit now concerning our domain. But before I do that, let's quickly look at the definition of cybersecurity. And cybersecurity is about the protection of computer systems and networks from different things, namely information disclosure, theft, or damage to the hardware, software, or electronic data, as well as from disruption or misdirection of the services they provide. Okay. So now we've read and seen the definition, and now let's go into our domain. So what are we talking about? So we're talking about aspects such as autonomous driving. So here you find an autonomous bus that is in Berlin, but actually in Rennes we also have some of these exact same ones. In Paris there are some that are already operating. You have Teslas driving around on the road, so autonomous driving is still a little bit the future, because not all cars are autonomous or all vehicles are autonomous, but at the same time it's something where we already see the technical possibilities. So it's close to being part of our daily reality, or it's even part of our daily reality for those using these tools. The second, smart cities. Smart cities, everything is interconnected. You have that in many cities already, or you have it in all cities already probably, even though you might not see it. So when you have, for instance, a water network that is interconnected via LoRaWAN or other communication technologies. And the third aspect is intermodal transport, so transporting goods over multiple platforms seamlessly, and this is also something that is reality today. These domains are challenging, so let's have a look at why they're challenging, what are attacks, and what can we do. So, first of all, what is getting attacked? Or what are the parts of these systems? So the first part of the system are humans, because all this is done to support humans, and also humans are interacting and working in all these kinds of systems. The second aspect are cyber-physical interfaces. So this is super important, because when you read the term and you understand what it means cyber, which is software, and physical, which is the physical space around you. And the cyber-physical interfaces, they do something that did not exist 5 years ago, which is you have now an interface between the software, so code that you're writing, and the physical world. So you have, for instance, a robot, and if the robot kicks you, you can feel it in the real world. And this is a game changer regarding cybersecurity threats, because that means before someone could take your computer, like your smartphone, attack it, okay, then your computer was maybe lost. Okay, bad, but still okay, it was only the computer. With cyber-physical systems and cars and all the other things I've shown before, like the smart cities and also the transportation of goods and people, they are in our physical world. And if now a cyber attack hits, it's not hitting only this computer thing, but it's hitting our physical world. You have trains that can derail, you have smart cities where things can shut down, in all the domains that I was showing before. And autonomous cars that, if you attack them, in the worst case, can become a weapon, because you can just direct them wherever you want. Important aspect of all this is communication, because the entities, they are not isolated, but they are connected, which is the paradigm of the Industry 4.0, for instance. Then you have storage, because data are stored, because the algorithms are working with data. And finally, the aspect that I want to show is computation, which you have locally, but you also have in the cloud. Okay, so now this defines some of the interesting parameters of the field I'm talking about with you today, that you probably also heard in the other talks already, but for cybersecurity, these are the most important ones for me today to talk to you about. Okay, so attack vectors. As I said it earlier already, all these are attack vectors. So computation, especially when you have computation in the cloud, someone and your cloud provider is not secured, someone can attack it. And even if it's secured, as you've seen with the 4-axis before, it might be that there are 0 days, so things that were not detected before, like in the operating system and so on, and someone gets into your compute resources. This is bad, of course. So yesterday, I think we had an outage of the AWS, one of the biggest cloud service providers in the world, and there are lots of services that are not working anymore. A cyber attack. Or it could also have been, of course, just a failure, but they invest a lot of money and so on in order to prevent that, so it's probable that this was caused by an attack. The cyber-physical interfaces. This is interesting because it's not only something that can attack you, but you can also use it to attack. So if you think, for instance, you have some surveillance camera in the garden and you would connect something, then this can be an attack vector. Or when you physically change a system, this might also be something that is affecting the software that's running in the back. Humans are probably the biggest attack vector because you can receive an email with phishing, you can install some software through other means and so on. So the humans are often the weakest part of the chain, of the security chain. Communication, of course, also something you can attack in the communication channel and so on. So also important. Plus, very important because it allows you to have remote access. That means even if you're at home, I'm in France now, I could attack you when you're in Germany or somewhere else in Europe or anywhere on the planet, just through the internet if your systems are connected to the internet. And lots of systems are connected to the internet. Storage, very important because it allows you to access things even if the software that provides access to the storage is secure. Maybe there are some side programs that are running that give you access to data. So what are attack properties? Security. Security for me is here especially that the system is doing its functionality so that only those have access that should have access, that the system is, the robot arm for instance, is doing what's expected to do. Privacy. So that means all data, and as we'll certainly talk about that much more, but I just briefly want to tell you something about it. So privacy, so that data that is related to you, that is protected against non-authorized access. So access by people that should not have access, which is even more than non-authorized because maybe they're authorized but not by you. And safety, of course, because as we've seen, these systems, they can attack your health and your safety, and therefore these are 3 key aspects of the attack properties that we want to secure. So what are we talking about? So what is characteristic for these systems? So it's characteristic that they are mobile. That makes it more difficult to secure them because they are not static but dynamic. The entities that do computation within, they often have low resources, which does not allow to have strong cryptography and so on. So this is a limitation that makes attacks possibly easier. The question is, are the resources managed or not? So if the car is with you, are you the manager or is someone else taking care of it? Who is the owner of the entity, which might be the software in your car when we stay with that. They are often critical, they are dynamic, the humans are interacting with the systems, they are connected, they are often working together in an opportunistic way. When you think about cars, for instance, and you're on the road, you don't know which cars you will meet, and they will start to work together in an opportunistic way. And the question is, are they secure? because when you connect different entities and functionalities, it's not clear that these entities and systems are all as secure as they could be, and the weakest part of the chain is defining the overall security of the system. Okay, so these are some recent attacks that you've heard of. So where lots of hospitals, and are lots of hospitals that are attacked. And there you often have ransomware that is attacking these entities, encrypting the data, and then wanting to have money from you. Security-wise, the effect is that the entities are not operatable anymore. So they cannot do their job. There are patients that have struggles, or in the worst case are dying, for instance. Then here we have an attack to an infrastructure. So this was earlier this year, I guess. Also a big ransomware attack. And this one here is the SolarWinds hack you probably heard of. And this one I put because it has an interesting attack, because that's a provider of update mechanisms, SolarWinds, and they had lots of customers to take care of their software updates, which is super important and interesting for security, of course. But they were hacked probably by a state entity, and then there were malicious updates injected into the systems, and this is of course super bad, because this is, you're injecting something into a security mechanism and then it's multiplying. Different attacks here are espionage, as goal, as probably in the SolarWinds case, phishing, when you get an email and click on something, and ransomware. So these are some key attacks. What are common risks? So there's a project which is called OWASP Top 10. And every year they are looking at, with a survey, they're asking important companies to give feedback on that. And this is the top 10 list. And you see the top 3 is broken access control. So how you authorize to get into a resource, cryptographic failures, and injection, like in the SolarWinds case, where some data was injected that should not be there. As the time is advancing, I come also to the end. So who is affected? Well, you're affected. So every one of us is affected. And therefore it's very important to get deeper into it and to look at the possibilities of cyber attacks. And as last point, I want to put the link to Edward Snowden, who revealed in 2013 attacks that were created by the NSA in the US, because this was in 2013 and the attacks were very advanced, because you've seen if you have an attacker with unlimited resources, then they can advance a lot what is possible. Today we are 8 years later, and you can imagine that it's probably evolved further, and things that the NSA or other secret services might have today will probably also be reality in the common cyber attacks by non-government entities, and therefore it's something to keep in mind. Okay, good. So I just showed the last slides. So these were the areas we're working on. And this is our experimentation setup. It's also interesting for you. I brought you some videos. So this is very interesting if you do cybersecurity research, because then you can really do experimentation, validate things, and also have the virtual interfaces, the visual interfaces via virtual reality is also something we do. And if you're interested in doing more, feel free to contact me. I hope I gave you a little bit of an overview on the field, and could also open you up to look more into it, because it's super important and it's really touching every one of us. So thanks a lot for the attention, and here you have my contact details. Yeah, okay, so thanks a lot for the question. So I would say, well, yes, we're getting there. So one thing we are looking at the moment, for instance, is exactly this ransomware, which I personally think is the biggest threat that we have for the moment. And with the ransomware, what's typically happening when you have a system is that the host gets infected, and the software that gets put on the host starts spreading immediately. And so a solution would be, if you detect it fast, you could isolate this one, and then it would be just this one is contagious and the other ones are still secured. And for doing such things, machine learning can add a lot because you have fuzzy analysis of what is happening. Digital twins can add a lot because if you have a digital twin of a system, then you can compare it to how the system is behaving, and if it's not behaving as you expect, then you can assume that it's an anomaly, and if you then have something that decides, like the machine learning that decides it's an attack, it's a ransomware, then you can reconfigure. Then you have an autonomous response. So I would say in the limited scopes that people are looking at, autonomous responses are coming. For me, there are two challenges. The first challenge is, of course, how to implement it, and I think machine learning and digital twins are the tools to go for. And the second one is how to get the human back in the loop. Because autonomous functionality is good, but at the same time, to assess the risks and to take the decisions is not necessarily only requiring the things that are part of the algorithms that do autonomous response, and therefore bringing the humans back in the loop. So the things that we try to do with our virtual reality interfaces, for instance, this for me is then the next step. So first you might create some mechanisms, but then to make them really usable, you also have the human in the loop. So my answer would be, it's coming. It will still take some time, but I think for specific attacks, we'll have some autonomous response available very soon that will be probably quite stable.